Yes, thank you for all coming and thank you for, making this happen. It's really great to meet so many software engineers and musicians and really great people. So I'm going to talk this evening a little bit about this simple electronic instrument. And it's called a Zoot. It's named after this guy, um, but he's a Muppet character. But don't tell anybody because that's not actually part of my branding, and I don't want to get in trouble with the Muppets. So I'll talk a little bit about how this project got started and what my motivation was. I've always liked to sing. I played piano as a kid. And years ago, as an adult, I wanted to get more into music. And my girlfriend at the time said, the recorder and playing early music might suit your personality. So I followed up on that suggestion and found a teacher by the name of Sarah Cantor, and I studied with her and had a great time. The recorder is a very accessible instrument to get started. All you have to do is place your fingers and blow, and you don't have to, develop your lip muscles. The people who play clarinet or oboe or trumpet, know how hard that can be. There are ensembles of recorders. This is a soprano, but they come in soprano, alto, tenor, bass, the different sizes. And it's great for early music, the music that was written for it. But the challenge is that the sound quality is not always suitable for playing with modern instruments. It has a limited pitch range and for each one. And you can't play loud and soft very effectively on a recorder. So if I'm going to turn, I got to show meeting and turn original sound on. Where is that control here? Man. Where's my Zoom meeting? All the technical problems of Zoom. Everybody's got the show meeting, original sound for musicians on. Okay. And can you guys hear that on Zoom? Just thumbs up, or maybe you should.
Looks like we can see you, like from your computer.
Yeah,
But the presentation is showing this, like on Zoom, we see this.
Yeah. Okay. No, we're good. I go back to Keynote and we should be able to. Are we back?
Yeah, we see your speaker.
Oh, I think screen sharing failed to start. Please try again later. We saw that OBS from Clay. I wonder if he's still, because it's not letting me share.
You're sharing, but yeah, Clay, I don't know if you are still sharing or trying to share. I do have multiple participants can share simultaneously, but I could make it one participant at a time and see what happens. Okay, back to multiple. This is what, yeah, this looks great on Zoom right now.
Okay, finally. Okay. All right, I was just trying to do a quick illustration. If you've ever played a recorder, when you try to blow louder, the pitch changes. So you have, that limits your ability to express yourself. Anyway, so being a tinkerer, as you heard in the introduction, and a musician of sorts, it was kind of natural for me to try to put my interests together and see if I could make something that was as easy to play as a recorder, but as expressive as a clarinet. And I was interested to see, I was interested in learning what I could do in the technology. So I'm going to show a video that I made very early on. to give you an idea of possible expressive capabilities. So I won't go through explain all the different gestures that I was doing there, but we can come back to that. And it's a little bit gimmicky, but I couldn't resist trying. So at the very beginning, my design philosophy was keep it simple. I would say almost minimalist. Make it ergonomic. I made it for myself, and I feel very comfortable with this flat surface and these places where you can feel where your fingers should go. And then do the hard work in a separate app on a smart device, on a laptop or a phone or whatever. Don't do any synthesis or sound production in here. This would be just the sensing, and do everything else elsewhere. In terms of the development process, I wanted to do it in small steps, build incrementally, take baby steps, and not worry too much about what I didn't know at the beginning, but learn as I went. So this was at the very first proof of concept that I made. You can see copper tape and electrical tape and tubing and rubber bands and popsicle sticks and solderless breadboard for people who know what that is. And so from there to this is a long process, lots of work. And the project incorporates many different elements. So on the device side, you have the mechanical design of the housing and the mouthpiece and the end caps and what have you. And inside, you've got the electronics for the capacitive sensing, which is used to detect proximity as well as touch. You've got the software that runs on the microcontroller in here, which people like to call firmware. And then the whole separate problem of the app, which does all the hard work. And I'll just point out one piece inside the app to separate out, which is the clarinet synthesizer, which I also built from scratch. It's an simulation of an approximate simulation of a clarinet. It's not based on sampling. So I'm going to skip a lot of stuff about the development process. And get right to showing you a little bit about, and I'm going to skip about the clarinet simulation. We can all, but if there are questions about any of these things, I'm happy to talk about all of it. So we'll go right to the GUI, and I'm going to stop share and try to share the app itself. So this is the screen you see when you start. It's the basic screen. There are three main screens to select, and at the top there are just two internal, since the clarinet is mostly what I play. You can decide whether you want to send MIDI output to another virtual instrument. And I'm not going to go through everything. It could be a really quick tour, and again, we can come back to anything. But I really, as an amateur, I really like this ability to transpose at will. So I play folk music with people, they're all playing guitars, and I'm not so great at playing by ear. I try to collect sheet music and read from notation sometimes. So I may have a melody that's notated in C, but they're playing chords in E, let's say, and then they say, oh, we're going to capo up to. So then I'm going to do that. So that whole thing is calculated for me. And so when I play, we're in the same key, and it all works. I'll also point out the touch display. So and Zoom may not keep up with this. I did some experiments, but you can see it here that it's picking up where my fingers are in real time. So that just gives you some confidence and feedback. Now the gesture screen, you can select the fingering system. So I play with recorder fingering because I learned recorder, but you can make a fingering system. There are some that come with it, and you can make your own that's similar to whatever instrument you like, or one that is more intuitive if you don't play any wind instruments. And I'd say the most important thing on this page is the sway and roll. So this has an accelerometer in it, 3-axis accelerometer. So besides getting breath pressure and finger positions, you get that motion information. So you can do a simple vibrato, change in pitch, and you can adjust like the sensitivity of that. So, if you want to go crazy, that doesn't make sense for most music. And usually I'm, at just a subtle vibrato. Now the strummer is something a little bit different. I built this so that I could have I don't play guitar, but I like to sing, so that I could have a crude kind of accompaniment. So I got the accelerometer, let me do something with that. So, this is kind of apropos of some of the things Clay was talking about. You select a set of a chord group. So I have the D major chord group here. And then you finger the root note of the chord, and then you can strum. And it is sensitive to, how vigorously you're strumming. And then there are a bunch of different adjustments, related to that. And again, we can come back to it. I just want to give you an overview and a quick tour. So I ran out of space for things that I was playing with. So I have the bars menu on the side, or the hamburger menu, or whatever people like to call it. 2 sections. The top is just informational things. And I'll just show you one, which is that you have the fingering reference right in the app. So if you select different fingerings, or you download some fingering that someone else created, it's the one that you've selected, you always have the reference available right there. And then I would say the most important thing in the settings section is presets. So you saw there are a lot of controls. Most of the time I don't change many of them, but if you're doing experimental stuff and you have different setups with different MIDI instruments, you may do all kinds of adjustments. You want to save everything as a preset so you can get it back. So that's what this lets you do. And you can say which one is the default preset when you start. So you don't have to even get to that screen. And then I'm just going to, I can't resist this. I've just been playing with this recently, proximity mode. So instead of recognizing fingerings, let me turn off the strummer because it's triggering kind of with my motion here. So I'm going to experiment with that for things like, I don't know, bird calls or whatever, or animal sounds or whatever.
Proximity to the sensor? That's proximity to the
Yes,
sensor.
so I'm getting actual proximity information from 7 fingers and 2 half sensors for the thumb. So I'm going to stop sharing that, share my presentation again. Where to go? Why don't I see it? Screens.
Under documents and stuff? No.
Application. This doesn't make sense.
You have to go back to Keynote on the left.
Share now what? Desktop 1. Yeah, okay. I think that worked.
Yep.
So I'm just going to show you a few seconds of a few demos just to give you a little bit more range of what. So the point of this is just to say you can play non-wind instruments with a wind controller. And I did not make this violin. This is audio modeling. It's one of their Swan instruments. And then, again, this is another example of the strumming. So the blowing and strumming can be active at the same time.
So here's to the rainbow that's followed the view, and here's to the friends that I know.
So, and you can
And here's to the
make it easy
song
for yourself because you can have a chord group that is just for the song that you're playing. So, if you need different flavors of, D and D major 7 or whatever, it's easy to, you don't have to think too hard. Now here I'm taking advantage of the fact that these sensors actually give. So you see I'm moving my finger. So this is like leaking or shading on a tin whistle or something like that. All right, that's enough of that. And gives you the idea. And this is a. So this is a kind of a theremin-ish sound.
Yeah, that's a thing. I can't remember what it was.
So and then that's all. Now I'm doing portamento or smooth glides between notes. So that was on that advanced gestures page that you can set up. So I'll stop there with the presentation and take questions about anything you guys want to know about.
Wow.
That's
Incredible.
Very cool.
Thank you.
Also, remote people, feel free to unmute.
Uh,
Be curious. I don't know much about like actual like commercially available MIDI wind instruments, but I'm curious if you like specifically try to do things that are different than those or more similar to those.
So I started this a long time ago, like in between paying consulting gigs. And at that time, I don't think there was any that was in this form factor, which is like almost identical in size to the soprano recorder. There is now, and I almost threw up my hands and stopped working. And I said, well, this is for me. I'm going to keep going. I don't know anybody else who does that the strumming thing, but that's not a primary use of
Very
it.
cool. It seems like it has a lot of nice features.
Yeah.
I have a question.
Yeah.
How does a proximity sensor work? Is it just like, how does it know how far away your finger is?
So the technology is capacitive sensing, and that is inherently gives a value related to the size of the areas that are overlapping and the distance between the two. Like you're between a capacitor has two plate, an electronic component that's a capacitor has two plates, and capacitance is determined by the area and the distance.
So it's sensitive enough that it can measure the capacitance even when you're like fairly far away from the.
Yes, yeah, and I can share a graph in real time of all the sensors which I use for debugging.
That'd be pretty cool to see.
Yeah, but maybe after.
So you're using a pressure sensor, but I'm guessing that you still, when you blow into it, the air can still go somewhere.
Yeah. So this is the exhaust tube here, and you can actually adjust the amount of the flow pressure ratio that you like by changing the diameter or the length of this tube. It can provide more or less resistance.
Like Bernoulli stuff.
Yeah, and you can also, based on that, you can set the sensitivity of the breath. One of the future developments is a lot of instruments will let you set the curve of like pressure to MIDI I don't, I have a curve built in. You can't adjust it right. You can adjust the gain of that curve, but not the shape of it right now.
How much does temperature affect the response and stuff like that? Like, do you have to calibrate it periodically, or is it?
So it calibrates when you turn it on, or you can in the app force it to calibrate. The thing that is, temperature is not a problem.
That's great.
The only problem is if I'm really nervous and I start sweating a lot,
Okay.
and if there's a sufficient amount of moisture on here, that will affect it. There is it does an automatic adjustment while you're playing, which helps a lot. But if you can see droplets of water, then you might need to recalibrate or wipe it off and recalibrate.
Oh, there's a question online.
Yeah.
It's okay. How much does the instrument augment or diminish the skills of a professional wind instrumentalist?
Say that again?
How much does the instrument augment or diminish the skills of a professional wind instrumentalist?
Well, since I'm not a professional, I don't know. I would love to have some professionals
Okay.
play it and make demos and give
You
me
have some friends?
and give me feedback. And I think it depends what you're after and what you want to do. I don't think it would diminish your skill.
Yeah, I imagine. I have a question. I don't want to jump in, but can you talk a little bit about the production process of now? Like, what does it take for you to assemble one of these or 10 of these?
Yeah. So the housing is.
Did you mean to stop on this screen?
No, I really meant to show you some pictures, but then I have to go to my
Oh, I see.
keynote
Okay, it's okay. No worries.
and it's getting
Yeah.
I need I guess I should have had a third screen over it.
We'll do it next time.
Yeah.
First round.
Yeah, so this is 3D printed with a resin process, and I send the design files to a company in China called JLC PCB. The end caps are printed with multi-jet fusion, as is the mouthpiece. And the printed circuit board, I also send design files to that same company. And I'm doing batches of 10 at a time right now. And I get those components back. I have to add a couple of components by hand to the circuit board, and then I do the final assembly, squirt the firmware
So
in.
you're the assembler.
I'm the final assembler, yeah. It's a very small operation.
They're all hand assembled.
That's
by
right.
The creator.
Hand assembled in Newton, Mass. Yeah,
Small batch.
yeah, small batch. That's right. It's what's that word?
Artisan.
Artisan. They're artisanal.
So I have a device called the Baz pipe, which is a electronic bagpipe that I got maybe 25 years ago. It's capacitive. It doesn't have a MIDI controller part. It doesn't have a breath controller because it's stimulating Highland bagpipe, which doesn't change how loud it is, right? And so you just sort of turn it on, you select a button whether there's a drone or not, and then you play. And yeah, it's interesting because I was going to ask about the same issue about the capacitive thing, which is sweaty fingers basically, right? Yeah, I think I would say this is it's really interesting to have that type of the bagpipe has simple fingering. I don't know if you've experimented with bagpipe fingering,
No.
but there's a couple different ones, but they're not. But it's really interesting that you have the breath input, because that seems like that opens up this kind of combination of at least the capacitive one for the bagpipe that I have, right? I'm assuming the responsiveness is similar. It's very responsive to the point that you can run your fingers over it to do you can think of it as like a sort of quick staccato triplet type of thing. I don't know if that works on there, but being able to do those very quick movements
Well, you'd have to try it to see what you think. So, for someone who is a professional recorder player, they may notice that there is, system latency. I'm using Bluetooth Low Energy, so that is kind of the fundamental limitation in terms of sampling rate.
What is the latency?
So it varies, but I would say between doing this and the sound, depending on, there's so many pieces of the system, but 20 to 40 milliseconds.
Could a glove help with the sweating or not? A special glove? Or
I don't know. It's not a big problem for me.
not?
I don't think it's a major. You have to be aware of it, but then you need, then you're reducing the signal you get,
Yeah, so
unless you get one of those gloves that they use for touch screens, right?
He has rehearsal or a concert. Actually.
Break a leg,
Yeah. Melrose Symphony.
have fun.
There's some.
Did you say that the breath sensor is at the mouthpiece?
No, the breath sensor is mounted on one of the circuit boards. So, when I aim for simplicity, it's not only simplicity it's a simplicity in manufacture as well. So they're just two flat circuit boards, and the sensors are the back of the circuit board. So there's a little tube. So, yeah, I could show you pictures, but.
So is the breath going through the breath sensor?
No, so the path is, I wish I could show you pictures easily. The path is, from here it goes out here, but there's a sense port. And since there's some resistance here, you build up pressure inside that mouthpiece.
How do you deal with the moisture accumulated in this place?
It'll just drip right out.
Just like a horn.
Yeah, it's not a problem. If it gets excessive, it can start to affect the pressure sensor a little bit. It's made to deal with a liquid, so it's not going to hurt it, but it can add like a little bit of baseline pressure when you're not blowing if it gets really bad. But that's, again, not a big issue.
Could you talk about how you developed the synthesis algorithm for the clarinet sound?
Yeah. So let me actually make the effort to figure out how to. I don't know if Zoom people are still seeing this. I guess so. That's fine, right?
Now we see your entire keynote.
Okay, great. So. So this is not mine. This is, I started by using a clarinet synthesizer made by a gentleman named Chet Singer. This is built in Reactor. Familiar with that?
Yeah.
Yeah. So that's a digital signal processing engine with graphical components. So the fundamentals of a clarinet is actually, this is very simplified, but the idea is it's a cylindrical tube, it's closed at one end, and it turns out you can simulate that with a delay line and a low pass filter, and this gain block at the end that determines you get the reflected pressure wave from the open end of the tube, and the reed is a nonlinear element. And so this is the basic circuit. And next. So there are a lot of there's some frameworks out there to build software like this. From the very beginning, I wanted to do it because mean, I really liked the Chet Singer's reactor clarinet, but that's not going to run on a phone or a tablet. And part of my project was I wanted to learn how to do it and build my own. So I developed this simple circuit framework. So a lot of software engineers here, so you know this is like a class diagram. The component is an abstract class. It can be either a primitive or a circuit. So you've got this recursive. You can have nested circuits, and so components are connected to each other with wires. And believe it or not, the first version of this I built in JavaScript and ran the clarinet synth in JavaScript. It helped a lot when I got an M1 Mac, more CPU. Then I ported it to C++ later. So here's a piece, just a random piece of the internals of the clarinet. It was automatic. The diagram was automatically generated from source code. The bore refers to the inside of the clarinet, and that it's not shown here, but the bore is the circuit, the timed crossfader. Those are both primitive. So just an example of how you assemble the circuit. And this is an example of the source code. So that in the C++ version, this actually goes through a preprocessor to produce C++ code. But you can declare, so it's more declarative. You can declare your switch bore as a circuit. It has these inputs, it has these outputs, it has these components and these connections. And then the most important thing is not shown here is what the actual code does on each time step of the sampling. So that's, I don't know if that's getting at any, if that answers your question a little bit.
Yeah, no, I was like curious. So do those components do like block-based processing? Like each component does its own, like processes a buffer at once and then it passes that around?
No, each component processes one sample.
So it's like sample-based?
It's sample-based, yeah.
Okay.
So you could not build this directly in what's it called, web audio,
Okay.
because you're doing everything in chunks. The components deal with chunks.
Yeah, and then does it compile down to like a single function, or is each component like a function call for like per sample?
So it's not optimized in that way.
Okay.
Yeah.
It's like a function.
So
call.
you're calling the clock method for each of the components in turn.
Okay.
So when a component, I mean, there are some details that to make it work right. Like sometimes not all the inputs arrive on the same tick, and you have to wait. You got to make sure you have all your inputs before you clock the component. So, so that's all worked out in the circuit framework.
Cool. I think we are coming up on time. There's so many great questions. I think people will want to probably have your contact, and we'll send that out at the end so people can reach you. Yes, great. There's an email.
Yeah, and even a QR code.